everyone, fifth episode of Machine Learning for Beginners series. So today we have Jineet Doshi, who is a data scientist at Intuit, and our usual three members, myself, Omkar Damle, we have Jay Shah from Arizona State University, and Aditya Zoglekar from UCLA. So I'm a grad student at NYU, and so I guess we can have some introductions from each of the members.
Yeah.
Jay, you can start.
Hi, I'm Jay. I'm a research assistant at Arizona State University, pursuing my grad studies in computer science with a focus on artificial intelligence. Yeah, that's all from my side. Aditya?
Hi guys, as always, Aditya here from UCLA. I'm a computer science student studying working there, and I also work at a research lab. That is one of the perks of getting into a grad school, and not taking much time, handing over to Jineet.
Cool. Thanks, guys. Thanks for inviting me for this. So, hello, everyone. I'm Jineet. I'm a data scientist at Intuit. For folks who don't know about Intuit, it's one of the biggest fintech companies in the personal finance space here in the US. So we create software for people to file taxes. We create software which does accounting for small and medium enterprises. And we also have this very popular app called as Mint, which does budgeting for common consumers. So I've been working as a data scientist since around 6 months now. And my team basically does machine learning for security risk and fraud across Intuit products. And it's been like a very interesting experience, I would say. A lot of challenges which I wouldn't have thought of existed, we are currently facing. So yeah, I can elaborate more on that later. I did my master's from Carnegie Mellon University. So there 2 years, I was particularly interested in data science and machine learning. I was involved with some research focusing on making neural networks more explainable. So yeah, that's about me.
Okay, so thank you for the introduction, Ginny. And so firstly, we would like to know how you started your journey as a machine learning engineer or a data scientist, and what was your inspiration for it?
Sure. So yeah, like machine learning in general, I think is like a very upcoming field. As you guys already know, it's like kind of pretty hot right now. Everyone wants to like get into it. I like my journey is there's like a lot of things that kind of like happened, and I just kind of like went with the flow, I would say. So I graduated from DISET in 2015, and I remember at that time machine learning, artificial intelligence, data science, it was hardly a thing in 2015, which is like not a long time ago. I remember in our final year, Professor Saurish Dasgupta, he offered a course on AI for the first time. And that time, like I was in my final year. And I know like a lot of people joined that course. Unfortunately, I did not. But I think that same year, I happened to come here to Silicon Valley to present one of my papers. And at that time, I happened to visit the Google campus in Mountain View, the Google headquarters. And Google was testing its self-driving cars outside the campus. And that's something which I saw in action. and immediately I was like fascinated. I was like, wow, okay, this is a game changer. Like if these self-driving cars actually become a reality, and we see them being like widely adopted, this has like tremendous potential to like disrupt a lot of things. So that's what like really got me interested in machine learning. I just went back, I did some research, like how do these things work, how do they know about so many things, how do they make decisions, more importantly. And then I got this fantastic opportunity to do my master's at Carnegie Mellon, which I feel is one of the best schools to do machine learning research, because CMU has like an entire school just for machine learning.
Yeah.
So some of the best researchers in the world are there. So even then, like, I didn't really know that I wanted to get into machine learning, really. But I started off by taking like one introductory course in my first semester, and that was like Introduction to Data Science, or sorry, Practical Data Science. That's what it was called. And it was like a very hands-on course. It was mainly like doing assignments and projects every week. And the kind of like projects I started doing, I found it like super interesting. Like you could do classification of say like dog species, or you could do predictions about how say a movie is going to do even before it's going to release. So a lot of these interesting projects, and I found that like pretty fascinating. So that's how I like decided to like dive deeper into it. And then as the semesters progressed, I took more machine learning courses, got involved in machine learning research as well. Again, like I said, CMU had like some amazing people in the field of machine learning. One of my professors, Professor Tom Mitchell, he is the author of the textbook on machine learning. He's also considered like one of the grandfathers of machine learning, having mentored people like Andrew Ng for their PhDs. So that was again a fantastic experience, just learning machine learning from him, knowing about like the different intricacies involved in machine learning. And then towards like my final semester, I got particularly interested in the field of making machine learning models more interpretable, because as we know, you have all these neural networks, CNNs, RNNs, all these kind of incredibly complex models which span like hundreds, thousands of neurons, so many hyperparameters. So it becomes difficult for anyone to know, okay, why did this model make this prediction? Whereas in a practical scenario, I think it's a requirement for a lot of these models to kind of be able to explain themselves. So that's something which I was involved with a bit. And like in the summer, I did internship at Intuit as a data scientist. So again, that was like in the same team which I'm currently part of, doing machine learning for security risk and fraud across all of Intuit's products. And that's when I came to know about a lot of like challenges that the industry is facing in machine learning. And I found that like pretty fascinating as well, because those challenges are like very orthogonal to challenges currently in academia per se, or academia is probably not even aware of those kind of challenges.
So before moving to the industry, can we have can you tell us about the specific courses at CMU, or the areas of machine learning which you thought you found to be interesting and which were useful later on in the industry?
Yeah, sure. So as a data scientist, like my current work, I feel definitely I use a lot of knowledge of data science, machine learning, but I feel my background in computer science was equally helpful because I feel like data scientists should also be aware of like a lot of the engineering challenges. That's equally important, especially when you're dealing with large scale data. Like I'm talking about like petabytes worth of data, which at academia no one has probably ever seen. But in the industry, you do have to face those kind of challenges. Like how do you scale? Scaling is always like a very big challenge, and that's when like engineering comes in.
So like
So
a big data course.
courses like introductory data science, like I started off with this course called practical data science. Like I said, it was like very introductory, introduced the basics of data science, about data cleaning, about transforming data, like the entire data pipeline, right? Where you first mine all the data, then you clean it, you transform it, make it feature ready, and then you feed all those features into a machine learning model. And then again, after you do that, you evaluate your model. So that was like, I think, pretty essential. Then I went on to do like some higher level advanced courses in machine learning. So again, like an intro to machine learning class, which covered like basics of machine learning, intro to deep learning. I was also interested in deep reinforcement learning, so I took some classes there. Then there was this interesting class on security and fairness of deep learning, which also I was involved with. And like I said, along with these, I feel engineering courses also really help. So as a data scientist, like I think most of us work out of the cloud these days because you have the potential of infinite compute, right?
Yeah.
And to run these huge models, you need to be able to scale your compute dynamically, which the cloud provides. So I feel taking courses in cloud computing definitely helps. I took a course in distributed computing, distributed systems, which I think was very useful. I also studied a bit of cloud computing infrastructure, like how does cloud computing work underneath. So again, I think that was pretty useful. One course which I didn't take, but now in retrospect, I think could have been very useful was some statistics, because that's another aspect as data scientists, which I feel is very important to know some statistics.
Okay. Jay, do you have any question?
Yeah. So, like comparing, you have both the experiences of working in machine learning projects and data science projects within the Intuit itself. So, how do you classify what are the differences between duties of a machine learning engineer versus a data science, or in general AI? How do you, in your opinion, define the boundaries between these three terms?
Right. Yeah, that's an interesting question you ask, because the way I'm seeing it currently, even in the industry, no one's clear on the
It's a lot of fuzzy.
bifurcations.
Yeah, it's a lot of fuzzy.
It is very fuzzy, and again, like from my industry experience, from what I've been seeing even here in Silicon Valley, that like the term data science is very overloaded these days. Like, you know, everyone wants to become a data scientist per se, but you could be doing like all sorts of things as a data scientist. I've seen people do just SQL as part of data science, like, you know, more of the analysis work. There are people like me who do a lot of machine learning work, a lot of data engineering as well, along with the normal data science part. I know, again, a lot of companies want to call people working on Excel as data scientists as well.
Yes.
So yeah, it's a very overloaded term, and at different companies, it means different things. So my advice usually is that when you're like interviewing for a position, always like ask them what exactly you're going to be working on, what tools you'll be using.
Right.
I think that's important.
Mhm.
Um, at Intuit, the way we look at it is that data scientists usually work on the modeling aspect. So we'll say be working on creating machine learning models, which would be useful for various applications. And then the machine learning engineer kind of takes over from there, where they'll take the model and then apply the engineering skills to make it production ready.
Mhm.
Okay.
Because again, from an industry perspective, being production ready is very important. You have tight SLAs that you need to meet. You need to integrate with all of these different systems that exist in your company. Um, so all of that engineering stuff is taken care of by machine learning engineering.
So, so if we were to define something between at least the boundaries between a software development engineer versus a data AI slash ML engineer, so is it something like a step plus one for ML AI engineers that you have to perform at least the basic specifications of a normal software development engineer, but in addition to that, you have also to work on ML models? Is it like a step up from software development engineer or something extra that machine learning engineer does, like having the basic knowledge for infrastructure is a must and then knowledge for machine learning?
Right. Yeah. So I mean, even as a data scientist, I feel you have to know like software. Like I said, you need to have knowledge of distributed systems, of the cloud, how to optimize your models, a lot of these things. But as a machine learning engineer, yes, uh, like primary computer science skills are a must. And then on top of that, you're expected to know the basics of machine learning as well, because hey, when you're like productionalizing a machine learning model, you need to know how the machine learning model works
Yes.
under the hood to kind of optimize it.
Right. Right.
And that's why
Uh,
right now here in Silicon Valley, there's like a big shortage of such kind of people, because it's difficult to find such kind of talent who's
Right.
equipped with like both the sides.
mhm.
And like,
I had a
yeah,
question.
yeah.
Sure.
Oh, I was not sure if I was audible or not.
Yes, yes.
Yeah. So you mentioned how this field is very new and a lot of people are still trying to transition into it. Uh,
Hmm.
so was your previous research experience, the field, was it relevant to machine learning or was it something completely different? And if it was pretty different, then would you say that it was your core computer science skills which allowed you to pivot quickly?
By previous research experience, do you mean like my research experience in undergrad or more
In
like
un-
grad school?
I think you did. You were working more on the Internet of Things side and in undergrad.
Yeah, yeah. Like during undergrad, like I said, I wasn't aware like thing like machine learning exists.
Mhm.
It was only in my final year when I came here to Silicon Valley that I came to know that such a thing exists. So
Mhm.
at that time, yes, I was more interested in mobile applications and the Internet of Things. That was like my BTech project as well.
Mhm.
But like I said, having like those foundations of either a data scientist or either a machine learning engineer,
Mhm.
like whichever way you want to go. Because at the end of the day, these are all like computer systems.
Sure.
So
Yeah.
you need to know how to program, you need to know how to engineer things, especially when you're dealing with production systems in the industry.
Mhm.
Hmm. So, since you have mentioned about industry, one question which is like nagging my mind is mainly how much math background do you need in the industry as a data scientist? Because uh, in the courses we have courses which are like which go deep into the math. There are some which give you the intuition but don't cover all the mathematical proofs. So what's your say on that?
Right. I think you don't need to go like that deep into mathematics, but you definitely need to know the basics of a lot of things. Like I said, I think statistics is something which every data scientist should definitely know, at least beginner level statistics. Even things like linear algebra, calculus to some extent, because again, when you're dealing with optimization problems like gradient descent, and whatever neural networks that exist out there, like you do need to know knowledge of calculus, linear algebra. So yeah, I would say you need to know the basics, because at the end of the day, you need to understand how these algorithms work in order for you to like optimize them or even like deploy them according to like say the different data sources that you have. So yeah, a beginner level knowledge should do. You don't need to like be a super good mathematician per se.
Yeah.
And like seeing at your profile, it seems like you have a variety of experience coming from your undergrad. Like you started off doing IoT things, and then you jumped on into like your higher degree, and then you moved on to machine learning. And Intuit is a like cracking Intuit interviews are something very phenomenal. So, what according to you you think is something that stood out on your profile that made you intern in something like a machine learning project at Intuit and then land a job at data science? What was something you think that okay, this is something recruiters do see or plus or minus some of the do or don'ts students should refer to?
Yeah, sure. So in my case, so the way it worked was I interned at Intuit as a data scientist, and they were happy with my performance during the internship. So they gave me a return offer for a full-time position. So that's how I landed up at Intuit. But even doing internship itself, I feel like all these projects that I did at CMU, all these class projects, all this research, all of that really helped because when I was interviewing, my manager or my to-be manager did ask me about all the details of all of those projects that I was involved with. Asked me like, okay, why did you choose this machine learning algorithm or the other? How did you do hyperparameter tuning for this particular model? Or more importantly, how did you clean the data? How did you transform the data? How did you come up with the features? Because then that kind of thing is important when you're in the industry. Um, so yeah, I would say like a lot of my work at grad school definitely contributed to this.
And apart from interviewing for Intuit, I'm sure like you must have also applied to other places. So what is the common procedure? What are some of the commonly asked questions for a machine learning or data science internship or in general any job procedure? What are the common things we should expect? Because we find a lot of questions on Glassdoor and Indeed, and we find a lot of questions being asked for software development positions, but not a lot of material that is available online for machine learning interviews or data science job interviews, internship interviews. What are some of the common things like people can expect out of those interviews?
Sure. So like I said, every company thinks of these positions differently. So like we just discussed, the term data scientist is like very overloaded right now. What a data scientist at say Facebook is different from a data scientist at Google versus a data scientist at Intuit. So they take interviews according to that. But usually the standard for data science is that initially during phone screens, you are tested on your analytical skills. So you'll be asked like some SQL problem or some query related question. and along with that, also your programming skills are tested. So um, like your standard software engineering problem, they'll slip in like one of those as well, just to see how good your programming is. Also, your communication skills are tested because many times you have to like communicate a lot of these complex analysis to executives and all these people. So at that time, like, you really have to simplify things for them to understand. So your communication skills come into the picture as well. So that's the initial screening. Then at the on-site stage, um, you're usually given a data challenge. So they'll give you like a small data set and you're expected to analyze that. And you're given like a day or so to do your analysis. So that's where you can use all of your data science skills, like just open up Jupyter Notebook and just start like exploring the data and then trying to like, come up with what interesting insights you can come up from that data and what kind of models you can build out of that data, which could be useful for the company. And then you're interviewed on that. That what kind of analysis did you do, how well did you explore the data, the entire data pipeline, data cleaning, transformation, feature engineering, to the machine learning part, and then the evaluation part as well.
Right.
Yeah, that's how it works. And add in like a bit of theoretical machine learning knowledge as well. So some basic questions about like probability, statistics, or how certain models work, for example, and why you should choose one over the other in certain scenarios. Yeah, things like that.
Right.
So I've noticed that a lot of these data science, machine learning jobs, they give preference to, say, PhD candidates. It's often stated that they prefer someone who's doing a doctoral degree. So how does a master's student stand out from that, try to differentiate himself? Or, his odds are obviously stacked against doctoral students. So how does he try to make up for that?
Yeah, so I feel that's actually one of the myths that usually exist, that data science positions are usually only for PhDs. I mean, yes, like to a certain extent, if you have a PhD, you have like some amount of experience with research, like all of these things that we discussed, things like statistics, probability, and coming up with just basic analysis. You have that analytical mindset during your like once you do a PhD. But that being said, I don't think like master's students are at a disadvantage. I have seen a lot of master students be data scientists. I've even seen people just having an undergrad degree be data scientists as well. It's all about like your passion and your skill set. So if you're interested in it, I would definitely say like do more courses, get involved in research. That's definitely a big plus. And yeah, like do like your computer science fundamentals well is also, that'll also help.
And like as you mentioned in one of the previous answers, like you started your structured journey into the masters or machine learning domain right after you came into HCMU, and that was like that was one of the very lucky parts that you started at a very structured path. But for people who are interested in data science and machine learning domain in the undergrads, and which is one of the most unstructured kind of education because you are taught a lot of basic stuff within the college. So how does he or she approach, like what kind of resources would you in your opinion suggest that he might should refer to, because it's a huge pool out of resources for you to get confused. So what were some of the things that you made your best practices to learn these things in the best manner?
Sure, yeah. Like in my case, like I said, I was kind of fortunate to have a school like CMU.
Yes.
So that definitely helped in a big way, learning from some of the masters in the field. But as an undergrad, my advice would be, first of all, like when you're in undergrad, I would suggest just explore, like just take different courses, just see what you're interested in. Like it doesn't have to be machine learning per se. You could do computer networks, information security. There are like so many different fields even within computer science right now. Robotics, electronics, so many different things. So just explore, just figure out like what you like to do, what kind of gets your heart pumping. That being said, once you realize, okay, data science, machine learning is something I want to look at, there are like some interesting books, I would say, that you could start referring. I know the textbook by Professor Tom Mitchell,
Yes.
that is a very good introductory machine learning book. It's called Data Pattern Recognition and Data Mining.
Yes. Yes.
So that's a good start. The Andrew Ng course on Coursera, I think almost everyone does that now. I think that's like a good beginning point as well for people who want to just see like what machine learning is like. And I would probably say you should also work on a bit of your math skills. So courses in probability, statistics, calculus, linear algebra. I know at DISCT, those were like core courses. So everyone had to take them.
Yes.
And like the usual computer science courses as well, like computer systems, distributed systems, cloud. Yeah.
I guess I have one question, Jay or Aditya. If you have one, you can ask. Otherwise, we'll start wrapping up.
Yeah. Yeah.
Um,
Yeah. Go ahead, Omkar.
So I had one question. So how does a typical day in your say work look like? How I mean, on an average?
Yeah. So like that's one thing I probably realized after joining industry is that like I think the challenges being faced by industry are like very different than the challenges of academia. So we have to deal with a lot of data issues per se. Like when you're in academia doing machine learning research, you have all these nice clean data sets given to you which are labeled. It doesn't work that way in the real world. Almost every company I know, the biggest problem is the data itself. You have tons of data, like petabytes, even more amounts of data at your resource. But then the problem is a lot of that data is like highly unstructured. So say some of the data was generated 10 years ago by legacy systems. At that time, your schema was entirely different than the schema that it is right now. So there's like a lot of effort in just making sure that the data is in like a proper format, it's properly cleaned. So yeah, a lot of like our efforts go around that. That being said, there's also a lot of work that we do on the engineering side, where, like I said, we deal with like petabyte scale data, basically. So that kind of data you usually never come across in academia. You never have access to such large amounts of data. So at that scale, a lot of the engineering questions also come in, like how do you scale your machine learning model? You have tight SLAs many times, especially say if your model is working at the login page, for example, of any of the products. You don't want your customers waiting like 3 seconds or 4 seconds for your page to load. So your model needs to like, featureize all of the data, give its prediction, and back in like milliseconds or even less many times. So how do you do that at scale? That's that's something which I feel I never thought about when I was in academia, but in the industry, it's something which we worry about every single day.
Okay. Yeah.
And of course, along with that, we work on a lot of experimentation. So the way any project usually begins is it begins with some amount of experimentation where we come up with a hypothesis that if we take this data from these sources, we can probably create a model to classify this or to predict this, which would help the customer in this way. So we create that hypothesis. Then we go on to validate that by again pulling up Jupyter Notebook, doing an experimentation, coming up with the right set of features, coming up with the right set of machine learning model along with the hyperparameters and all of that. And once that is done, then comes the productionalizing stage where we look into all these engineering challenges. That okay, we have this model right now, we have these data sources coming in at this rate. How do you want to scale it? How do you want to make sure that this meets our SLAs? So you have to then think about, okay, how do you partition data across like hundreds of different clusters? How do you efficiently use things like MapReduce to parallelize all your computations across all of these clusters to again make sure that you're hitting your SLAs?
Okay. So that was quite uh, like getting the perspective from the industry is helpful always, and we'll make sure that during our academic journey we keep those points in mind. So just to wrap things up, based on your industry experience, do you see any upcoming trends in machine learning, any like across NLP or reinforcement learning, or any new trends which haven't creeped into academia yet?
Um, so yeah, I feel like a lot of trends actually begin from academia,
Uh,
and
yeah, I meant in the coursework actually.
yeah, I feel a lot of like trends do begin from academia, and then industry starts looking at it and they become interested in it, and they're like, okay, how we can apply this practically. Um, but yeah, like machine learning in general, like being here in Silicon Valley, I can totally see it's a huge thing. It's definitely upcoming. Almost every company here is looking for data scientists, machine learning engineers. They're all hiring. I think everyone sees value in just basically doing basic form of pattern recognition and like automating a lot of their tasks. There are like some amazing applications that are coming up. Just like 2 days ago, I was reading this AI report, which was talking about like some of the recent advancements that are coming up in the field of machine learning. It's being applied almost everywhere now. So many interesting applications which like I would have never really thought of. Um, People are using machine learning in healthcare. That's huge now with all this health data that's available. And again, that's on the standardization. The data standardization is another problem in healthcare because none of those records, the electronic healthcare records, are standardized in terms of schema and those things. So I know people are using machine learning just to standardize a lot of those data sets and then work out of that to do predictions. I know a lot of pharmaceutical companies are using machine learning to come up with new drugs. That was something which I had never thought about. So drug discovery is now being powered by machine learning. You have all of these standard applications which are always there, things like your conversational assistants, which are becoming better and better. If you look at Google Assistant with Duplex, what they managed to achieve. You look at Siri, which is improving again every day. A lot of interesting developments there. Self-driving cars continue to be like a hot trend with tremendous amount of potential. Um, Again, like a lot of challenges still to be solved as far as the self-driving car space is concerned. And again, that's where like a lot of machine learning comes in. Another interesting area I would probably point out, which I came across recently, was the use of machine learning in computer systems itself. So when you think about uh, your scheduling algorithms, like cache eviction policies, for example, you have till now you've had these traditional things like least recently used or round robin, or you had like all these fixed algorithms to do cache eviction or scheduling, which was managed by the processor. But now, just imagine what you could do if you applied machine learning there to study patterns of access. So take the example of the cache itself. If you already know from your historical data what kind of pages do you tend to access more, you can make eviction decisions based upon that. So right at the system level itself, you could apply machine learning to optimize computers. A lot of, like I said, all of this requires a lot of advancements in hardware. So you see TPUs being, being worked on at Google. I know Amazon, Microsoft, they are also rumored to be working on their own hardware chips. NVIDIA is always there doing interesting work with GPUs. So a lot of things working even there in hardware. So yeah, the future looks exciting. A lot of interesting challenges to solve.
Yeah. So with so many applications, there are sure many jobs up there to grab. So
Oh yeah, for sure. Like I said, I like go to a lot of these conferences and like a lot of these meetups here in Silicon Valley. Almost everywhere I go, I know like people are just like, oh, we're hiring. We need people. So I think it's a great time to be in the field.
yeah, surely.
Yeah.
Okay, so I'll just start the closing remarks. So thank you, Jineet, for taking your time and discussing your experience and what you learned along the way. We are sure this will help upcoming students and professionals who want to enter the ML field and improve in it. So thank you, Jaya and Aditya, for helping with the webinar.
Sure.
I
Sure.
guess
Yeah,
so.
thanks a lot, guys, for this. I think this was definitely interesting even for me, and I hope the people find it useful.
Yeah.
Sure.
Okay. So thank you. I guess we can close now.
All right, yeah, have a great weekend.
You too.
Yeah,
Yeah.
you too. Thank you so much.
Great weekend.
Sure.
Bye.
Bye.